We will now write the polynomial whose graph is shown here. So this basically represents the graph of the polynomial p of x. And so to write the polynomial p of x, we need a few information which we could get from the graph of the p of x. That is, we need the zeros of p of x as plus the y-intercept of the p of x, which we can get from the graph. When you look at the graph of this polynomial p of x, we see that x equal to negative 4 is 1, 0, because the graph intersects the x-axis at negative 4, as well as the graph cuts the x-axis at negative 3. So we have two zeros, negative 4 and negative 3. And we also see another 0 at x equal to 1. But this one has a multiplicity of 2 because it touches the graph at x equal to 1. And let's also identify the y-intercept. The graph intersects the y-axis at x equal to 0. So we see that the y-intercept is 12. And so we have the information that is zeros are negative 4, this is negative 4, negative 3, and 1 with multiplicity of 2, and the y-intercept of the graph of p of x is 12. Now let's write the polynomial p of x. So I write polynomial p of x, and this equals, I put this constant a, which is a polynomial constant, times the factors for each of the zeros. That is, we write a linear factor for each of the zero. So I put x minus of the first factor is minus 4, and another factor for another zero, that is x minus of minus 3. This is for the 0 minus 3. And these two are multiples of having a multiplicity of 1. So I don't need to put any power to this one. Or it just consider that they have the power of 1. And then I put another linear factor for the 0, 1. So I put x minus 1. But since this has a multiplicity of 2, I write down this as a power of 2. Let me simplify this first. So we have p of x, and this equals a is the polynomial constant, times x minus of minus 4 is x plus 4, times x minus of minus 3 is x plus 3, and then x minus 1 quantity square. Now using the y-intercept information, we can determine the value of a. So we have to plug in at x equal to 0, p of x equal to 12, because the y-intercept is 12. So replace p of x by 12, and also put x equal to 0 in this function or this polynomial. So this is a times of replace x by 0. It becomes 0 plus 4 times 0 plus 3 times 0 minus 1 quantity square. So let's determine a from this one. So this gives 12 equals 0 plus 4 is 4, 0 plus 3 is 3, and then 0 minus 1 is minus 1. But minus 1 quantity squared, and this equals minus 1 multiplied with itself 2 times, so it is 1. So this is 1 here. And so we have the equation 12 equals 4 times of 3 is 12, and then 12 times of a is 12a. So this gives a equals, we divide both sides by 12, we get a equal to 1. And so we have now determined the value of a. We can plug it into the polynomial equation. So therefore we get p of x, and this equals 1 times of x plus 4 times x plus 3 times x minus 1 quantity square. And so this is the polynomial. I can just remove this one because 1 times of all the linear factors will be the same linear factors. But this is in factor form, which we can give it in powers of x form. So for that, we have to multiply each of the terms and then give it in the powers of x form. So for that, first I'm going to expand this using this binomial. That is, I can use this binomial identity, that is a minus b quantity squared, and this equals a squared plus b squared minus of 2 times of ab. And so I can use this for the expansion of this binomial, that is x minus 1 quantity squared. Consider this x as a and this 1 as b. So therefore this becomes x squared plus b is 1, so it is 1 squared minus 2 times of a is x and b is 1, and so this reduces to x squared plus 1 minus 2 times of x is 2x times 1 is 2x. So it is x squared plus 1 minus 2x. And so therefore, this p of x can be written as I put the first two factors as it is, or I can also multiply or FOIL this out. Since these two are linear factors, we can write down this in quadratic expression form. I can write down this as x squared plus we sum these two numbers, that is 4 plus 3 is 7x, and then we also multiply these two numbers, 4 times 3 is 12, so we just put this as 12. So we have multiplied or we have foiled this two linear terms, and then the expansion of this x minus 1 quantity square, which we have already found. I'm going to put this here, that is x squared plus 1 minus of 2x. Now we can still multiply these two factors. So I'm going to put p of x. We have to multiply term by term. So first I consider this x squared and then multiply with all the three terms in the second brackets. So x squared times x squared is x power 4. Then x squared times 1 is 1x squared. And then x squared terms negative 2x is, I put this negative 2, and x times x squared is x cube. Now I consider the second term, that is 7x, and then multiply with all the three terms in the second bracket. So 7x times x squared is 7x cube. I'm going to put below this x cube term, and then 7x times 1 is 7x, so I put this 7x separately, and then 7x times negative 2x, this equals, we have to multiply the numbers, that is 7 times 2 negative 2 is negative 14 x squared, so I put this below the x squared term. Okay, now let's do for the last term in the first bracket, that is 12, and then multiply with all the terms in the second bracket. So 12 times x squared is, I'm sorry for that, that is 12x squared. So I put it here, 12x squared, and then 12 times 1 is 12. So I put this 12, which is a number, and 12 times negative 2x is negative 24x. So I write it below the x term. Now we have to add all the terms. We have to combine the like terms. So the first term or the fourth power term is x power 4. Now I'm going to write this term. 7 minus 2 is plus 5. So I put 5x cube. Now I add all the x squared term. Here we have one x squared term, and this plus 12x squared term. This will be 13x squared term, and we also have negative 14x squared term. So when you add these two terms, we get negative x squared term. Now we add this 7x with negative 24x. So 7 minus 24 is negative 17, and this is negative 7x, 17x, plus the final constant term is 12. So we see that this is the polynomial using the graph information of the polynomial. That is, we have x power 4, and write down this p of x, and this equals x power 4 plus 5x cube minus x squared minus 17x plus 12. So this is the required polynomial equation. P of x equals x power 4 plus 5x cube minus x squared minus 17x plus 12.